Hey, Algebra 1, Catlin here with your cool down help for Lesson 8, Caught in a Tree. Interpreting and creating these graphs of functions that matches a story. A child tosses a baseball up into the air, and on its way down, it gets caught in a tree for several seconds before falling down to the ground. We need to sketch a graph that represents the height of the ball h as a function of time t. So let's start there with our graph. Height of the ball is going to be on our y-axis because that is our output. And then we're going to have a function of time down here, t's, and height is our h. And let's just put height in feet, and we'll do time. We're throwing a ball up in the air, so it's only going to be in the air for a matter of seconds, although it gets caught in a tree for a while. So we got to include and label a scale for each axis. So we got to tell how far we're counting. We got to label everything, which I think I've done a pretty good job of starting. Now we need to pick some logical scales. And for a ball getting thrown into the air, a kid throwing a ball up in the air is, it's a child. So we're not going to get more than, I would say, 40, 50 foot in the air. He's not going to be able to throw it much further than that. So if we go by 5, 10, 15, 20, 25, 30, we could probably count by fives. 10 would be the most I would go by. 10, 20, 30, 40, 50, 60. But I don't see a child, like I'm thinking of my 2-year-old. He could throw the ball maybe 15, 20 foot in the air. So if it's a kid, I'm going to go with 30. We'll just go with that. So 5, 10, 15, 20, 25, 30, and then 35 if needed. And then, okay, time that a ball is in the air. So I throw it 1, 2, 3, 4. Okay, it gets caught in a tree. 5, 6, 7, 8. On the way down, 9, 10, maybe 10, 15 seconds. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think we could probably just count by ones down here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. So I think we've got everything labeled. We've got it scaled. Now we can tell the story. Now, when the child tosses this baseball up in the air, the ball is probably starting at a height off the ground. He's not going to hold the ball on the ground and then throw it up. He's going to hold it probably at about waist height and then fling it up in the air. So it's not going to start at the origin. It's probably going to start, I'd say, around 1 or 2 foot above the ground. So I'm going to say that my graph's going to start here. And then throwing a ball up in the air, 1, Mississippi, 2. It's probably going to reach its pinnacle probably around 2 or 3 seconds. So it's going to reach maybe, I don't know, 25, 30 foot. Let's go with 25 as our height after about 2 seconds. So the ball gets thrown up, and then it starts to lose velocity, and it levels off, and it reaches its maximum, right? Now, on the way down, after maybe about 2 or 3 seconds, it hits a tree. Let's say that it hits a tree at 3 seconds. So it gets caught in the tree right here. Now, when it's in the tree, it's on the branches, and it might be moving around a little bit, but it's not losing height because it's stuck. So it's going to pretty much stay there. And it says for several seconds. So 1, 2, 3, at least 3, maybe 4 or 5. So we can go on for a little while. As it moves around down the branches, it might slip and fall a little bit. We don't know, but I'm not going to be super tedious about that. So let's say that it goes on until about 7 seconds. And then it finally, at 7 seconds, is like, all right, I want to finish falling to the ground, which would take it just a few seconds to get down. And it's not, unless he catches it, it doesn't say he catches it, falling to the ground. So it's going to go all the way down to the ground. And let's say that it takes about 8 seconds for that to happen. Okay, so throws up, reaches its height, comes on the way down and hits the tree, gets stuck for a little bit, and then it finally falls down to the ground. And that tells the story of the kid throwing the ball up in the air and then getting caught in a tree for a little bit.